another live stream from Damn Vulnerable DeFi. Let's see the test this chat. Looks like everything is connected. The thumbnail is not updating. I don't know why, but we don't care, right? The chat is working. So let's go for the next one thing, right? Here we have free rider, a new marketplace offered down valuable NFTs. I think it's the first time we see NFTs, right? Has been released. There's been initial mint of 6 NFTs, which are available for sale in the marketplace, each one at 15 Ethereums. A critical vulnerability has been reported, claiming that all tokens can be taken, yet the developers don't know how to save them. They are offering a bounty of 45 Ethereum for whoever is willing to take the NFTs out and send them their way. So 6 plus, so it's kinda less, right? Yeah, it's kinda half the price. The recovery process is managed by a dedicated smart contract. You have agreed to help, although you only have 0.1 Ethereum balance. Oh, poor man. You are poor man. The devs just won't reply to your message asking for more. Oh, true. If only you could get free Ethereum, at least for an instant. So for an instant, we have a little clue here that we're gonna need to do some flash loans, right? So let's open Z. We're gonna go with why it's not dark mode. So let's see. Let's try first with Z. I should be changing my microphone of position. Let me know if the audio get too low, because I need to get my keyboard close to me. Right. I have some strawberries here, organics. Very cool, very sweet. All right. Okay, they're asking to update the IDE. Okay, well, let's see some release notes. So the AI was self-hosted OpenAI. Nice. Added some stuff. Git, language. Let's see about performance. Memory footprint. Okay, that's good. Language server. File watching notifications. Nice. Diagnostic counting badges. Edit button. Improved multi-cursor. Debugs. Panels. Performance again. Nice. Fixes bugs. Okay. Crashes. Crash, panic, crash. And breaking changes. And truck removed models that have been deprecated. Okay. Removed and used Git actions. Nice. Okay, we got a good updates here. Let me open the Twitch page. I need to check something here about the statistics. Where is the room? Okay, we need 25 follows more. So if you guys can follow in the Twitch, I'm gonna be thankful, grateful. Okay, we got one follower last stream, so that's nice. Okay, so let's study. I don't know why. Oh, they changed it. Oh my goodness. Oh, I'm using the shortcut for this. That's why I cannot use this shortcut. Okay. So free rider is this. That's the test. Let's close the others. Let's open the source code, README, and NFT. So let's start with the NFT marketplace. So you can see fixed version, Open Zeppelin, and some NFTs. And that for some reason it's not working. Go into definition. So this says that the NFT is here. Indeed. Maybe I'm too big. So we have here the ERC721, that's NFT with the burnable and ownable roles. Okay. So the minter role here is defined as role 0. We have the sender as owner, and also it's the mint roller, and we have safe mint function with only roles, and these take nouns get incremented and create the token ID incrementally. So far, so good, right? Nothing to worry about. So here we have free rider NFT marketplace that has reinsurance guard, and then we have the recovery manager. Recovery manager, they have a receiver for NFTs. So that's kind of important here, right? So they have some rules to receive in the recovery. So the NFT address that was defined in the constructor means that the NFT itself cannot call these, right? Oh, the NFT need to call these, right? Sender need to be the NFT, otherwise they revert. The tax origin, that's a little dangerous. The orange means who initiates the transaction. That's different from message sender. It's important. Here maybe makes sense because he are telling about origin. Need to be different. No, need to be equal to the beneficiary. The beneficiary here also in the constructor, and it's immutable. So that's 3 immutable. And the contract gonna pay the bounty. Maybe they have a problem in this contract. Maybe. So here the value should be different from the bounce. No, sorry. If different, not enough. So the bound is defined here. So we need to define the bound and also send as Ethereum. So the contract holds some money. And here they do some transfer. The transfer recipient, what the hell? They're gonna increase and then check if this is equal 6. And then they're gonna take the data that should be as address and then just pay. So what is happening? So we have received as private. So it means this is 0 and here it's 1. So I need to pass here 6 times. 6 times until I get. Okay. We have something here also said that token ID should be greater than 5. No, sorry, less than 5. Because if the token ID is greater than 5, they're gonna be invalid. So we accept 0, 1, 2, 3, 4. See, the NFT owner of the token ID is different as this. So it's still not owning the token. So basically they expect they received the token, right? So you're gonna send the token for this. Okay. Yeah, we have here some more information. That's opening the wrong place. By the way, that should be 2, right? 2 for code, 1 for D. So you can see here, not fungible token standard, and here we have also it's good to see some security specification, right? Here, handle the NFT receipt. Smart contract call this function on the recipient after a transfer. This function might try to revert and reject the transfer. Return of this magic value must result in the transaction being reverted. Other than the magic value. The magic value is this. So we need to implement these. I mean, they should be implement these for us. Then they have the metadata. Where you inform, and I think we return the schema, right? Yeah. Here the read my point to JSON find the conforms the metadata. Yes. All right. So yeah. Also here we have the NFT set approval for all owner. So basically they allowing the owner interact with the NFTs. Okay, that's a known reentrances, so we cannot re-enter. Also, we see have a lot of parameters here. Let's just check. That's operator from. So they are ignoring the two. So we have token ID and data. Great. So we have these. Now we have the marketplace. So the marketplace has the NFT, have some offers count. Here we have a token and price, token ID and price. That should be all 15. Some events, some errors, and the constructor. So when they construct, they also send some money, or I mean, they expect some money, and they expect because these expect, no, these not expect. So token is created. This contract got the mint role, but they renounced the ownership. So the ownership now is set to 0. And then they mint how much NFT they what here was 6, right? So basically only the sixth NFT should be paid for the recover. That makes sense because the recovery, because they are incrementally here and they're not reverting, so we need to call these 6 times to be able to take the value. So because they check the receiving here for each one, so that's funny, right? Because I can send the same token. So that's the assumption here, and that I received the 6 tokens, but that assumption is wrong because it's true that I need to just run that function 6 times, even if the token ID is the same, right? Because I don't check. I check if I'm a owner. So in theory, I just need to call this function 6 times to receive this with 1 token only, right? So maybe I don't need to buy all the tokens. That's something to note. Maybe I need to go audit and just need to call these 6 times, even if the token ID is still the same. They assume that they have all the 6 NFTs to deliver or to pay the bounty. Yeah, that's a bug. That's a wrong assumption. Okay, let's see if we can explore these. So here we have the amount of tokens, NFTs. They have an offer many, but the token is IDs. If I'm not mistaken, we start with token IDs with this 1 in the safe mint. No, it's 0. So we start with 0, go to 5. So 0 to 5, 0 to 5, 0 to 5. So here we can token IDs and we have prices for each one, right? That's no reentrancy. It's offer many. It's open. These are gonna let's check. So if the amount is 0, it's invalid. If the length is different, that's invalid. Then take the amount based on the token ID amounts, and then just run for each one. The offer one, we expect token ID and price. That's private. So only way to access offer one, it's for offer many. All right. That they do these checks. Great. Okay, he say this case saving because he's reading from storage only once instead reading every time here. I think the compiler already do the optimization, but why not, right? Here, if price is 0, that's invalid price. If the sender who is calling the function is different for the token owner. That's not the owner. So the owner is the only one to able to offer. Here in the beginning, the owner should be the marketplace. So that's strange, right? Already. So, oh, no. So save me to sender. So who calling marketplace is the owner. Then they can call offer. Great. If the token get approved, if not mistaken, return address that is approved. If it's get approved, token ID is different than this, and it's approval for raw. For this, it's false, so invalid approval. So let's check these two. You can see here, get approved and approved for raw. So here the address that owns NFT. So we need to inform the address that owns and the operator that acts on behalf of the owner. So it's checking if this owner address has allowed this operator. That's happening here. You can see here. So enable disable approval for third-party operator to manage all the message sender assets. So if we get approved to manage the assets that they hold, we can do whatever we want with this. And okay. And get approved address for the single NFT. So the address approved for this NFT or 0 if that is none. Okay. So basically they are checking if that's operator, right? Yeah. They are checking that who is calling is really the owner. If they also approved this contract to do stuff, so we need to do approved. So we need to do set approve for raw probably. Yeah, they didn't do here. Probably in the test they're gonna do. So okay, so what's happening is that they offer, we put a price. They have also an assembly here to get saving where they store, save store, right? M store, memory, S store, yeah, S load, no, that's storage, store, the M memory. So they load the 02 address. Inside these, they have a pointer probably. They're gonna add one and save it again. So basically, you are doing incrementally here. Just so incrementing something. What exactly they are incrementing? Not sure. Because we are not using these, right? 02. It should be some special area in the memory. The store. Oh, sorry, that's the storage. Oh, so storage is these here, offer counts. That should be 1 and 2. Because it's slots. Wait, slots start with 0, right? Okay. Anyways, they are incrementing the offers count. Okay. So they have a buy money where you just call buy and it's payable. So we need to provide money in Ethereum. They're gonna check if they have a sufficient pay. So they check the price, token is not offered, So try to take a token that's on offered first. We're gonna revert. If the value you send is less than price to pay, revert, and then decrease the offers count. So they're gonna remove the offer counts. Then they're gonna call token safety transfer from owner of the token to the sender who is buying and paid the token ID. Cool. Pay seller using a cash token. Okay, they are assuming after the transfer, the token owner is the same because they are taking this underlying token and that it's cash, right? That variable it's cash. This it's already updated after the transfer. This is not. If they get updated, they're gonna send the money for itself. So basically paying for free. We could check the ownerships, change it later on. I think, I don't know, it's a little strange anyways. And then they have a receive Ethereum. Okay, I'm not seeing the call for the unreceived, right? No, see this. Okay, I forgot the looks for every single thing. And that's very annoying. Okay, so the transfer from inside called this. Great. So we can assume that it's called. So here, after transfer, if we make the transfer or the buy be called by the recovery manager, I think it's not a oh, that's possible. No, that's not data. Wait. No. Okay, that's data is the recipient. If we call with data, don't think it's the case here. Wait, if that's not the, oh, wait a sec. Okay, how did I expect? How did I expect I have some data here? For this, I need to be calling this 1, 2, 3, 4. Okay, let's see the test. So now we can see what's happening here. So that's the price, amount NFTs, marketing place, initial balance. initial, I have 0.1 Ethereum. The bounty initial reserves on Uniswap V2 pool. Okay, so we can see already that we can do some shenanigans here, right? Still not clear. Even if I get all the money necessary, it's still not clear how I'm gonna buy this. I need to buy everything, then send to the contract. But how am I gonna send them the address to receive the bound? Okay, that's something to think about later. But yeah, okay, the setup, how the setup works. They give some money, they create a token. Here's the deployer, so that's the owner. The token, they took the router here. They approve some reserve, they did some deployment, they create a pair, they get a pair, and here they deploy the marketplace for NFT. So the marketplace will automatically mint amount of NFTs to the deployer. Exactly, you need to pay. Marketplace initial ETH balance should be how much? 90? Yeah, 90 ethers, and here should be 6. So the marketplace has money. This has money. Why they have money? Wait a second. Why? Why they have money? Let me see. Just forgot why they receive money. They receive money here to pass for the. No, it's not for this. Because the buy money, it's already payable. It's already gonna receive money and praise to pay. I see. That makes sense. So they're gonna pay the owner. Who is the owner of these tokens? Is the deployer? Let's see. So token save mint to sender, right? So who is sender? The deployer. Deployer has ownership on the NFTs. Yeah, there's something here. Okay, let's say we send 0.1. That's the problem, right? First, I need to do the offer. So let's see how much they did the offer. So get a reference in the real hack. We don't have like a test with this. You need to like fork the blockchain something locally, then investigate the data, and then create your test files for do the POC proof of concept. So get a reference to deploy NFT contract, then approve the marketplace to them. Then okay, sure. We're gonna need to do something like this. Maybe not these anymore, but these. Open offer in the marketplace. So 6 in the same price for everyone. Should be 15. Offer many. Now they have the prices. Deploy recover manager content, adding the player as the beneficiary. Okay, that's great news. So we are the beneficiary for these. That's good, I think. And let's see. So beneficiary, the NFT, who's the owner. NFT set approval for all. If they hold approval, remove operator as operator for the color. Operators can call transfer from say for any token only by the exactly. But the recover manager don't really own nothing. Anyway, I think we can freely ignore this for now. And then they end the bound. They check if it's two, it's equal. Great. So they do some assumptions. That's our test. And what they need to do. So the cover owner extract all NFTs from this associated contract. So they're gonna become this address. So we need to approve for this address probably. They're gonna do transfer from the recovery manager, that's the contract, to this from 0 to 6. And then they're gonna check the ownership. Exchange must have lost NFTs and Ethereum. So that's something they're gonna need to don't have Ethereum. And the marketplace offers count should be 0, so they're gonna decrease until 0. We need to buy. The balancing should be less than the initial. So we need to take some. Player must have earned all Ethereum. So the player should be has the bounty. At least the bounty. It's a greater than or a grade equal than? Okay, gonna assuming it's greater than. And here they check if the recovery manager has 0 balance. Okay. Cool. We have the Uniswap. The Uniswap has 2 tokens and they have Ethereum. So they have 9,000 Ethereum. And I don't think I have some token. Do I? Do I have some token? This token, it's the NFT? No. They have some token here. And the token is created here. Okay. I think we can take doing flash swaps, right? We can take this money. We can unwrap this. Then we get Ethereum. Then with Ethereum, I buy everything. They're gonna, yeah, let's pretend they're gonna pay. They're gonna pay. And the last one, so I need to send for these, right? The beneficiary here need to be myself calling the first call. And always gonna be me, so it's not a problem. And here they have a data. Okay, safe mint also checks. Oh, of course, safety mint also checks. That's virtual internal. Yeah, the checks, they're gonna checks. All right. So this is the bound. The recipient here, I care. Yeah, maybe. So I need to put data. To put data, I need to be able to call transfer with data. That's okay, right? Because I'm gonna call this from outside if I take the money. I have some interfaces from the last exercise, right? Maybe the contract here. That's even better. I wonder where is the router? They are using the factory and the router. The router it's added the liquidity. Then we have the pair. So if we take the pair, we can say swap. the swap is expect I transfer money for them, right? I don't have tokens. Nobody has, right? I has only this Ethereum imbalance. Now is the when the creativity get in play, right? Yeah, what's bugging me it's this a lot of Ethereums here, but the marketplace don't have way to wait. The constructor call. Yeah, but I cannot call constructor, right? Can I? No, I can't. They have the price. I need to pay, right? Why it's freezing? Okay. For some reason I got freezed. And I got back. I don't know why it's freezing. Maybe it's time to go sleep.